All right, so let's go ahead and try a practice problem with this integrating a function over a surface. And what we're going to do is we're going to try to, for g equal to xz plus 2x squared minus 3xy, and s, the area of the plane, 2x minus 3y plus z equals 6 over the unit square. Two less than or equal to x less than or equal to 3, and 2 less than or equal to y less than or equal to 3. We're going to find the surface integral. So kind of the hard part here is evaluating all the different pieces. So our function that goes inside the integral, the thing that we want to evaluate the surface integral of, or the thing we want to think about across the entire surface, is this g. Oops. And then the actual surface we're thinking about is this plane right here. Oh, sorry, that was 2x, not 2 minus x. And then the piece that we kind of have left over that we haven't used yet is this. 2 less than or equal to x less than or equal to 3. And 2 less than or equal to y less than or equal to 3. And what you kind of have to recognize here is they're saying that we're finding the integral over the surface S above the unit square given by those two equations. So in this problem, they're actually being really nice, and they're giving us the region R below our surface. And even though it doesn't appear in the thing we're supposed to find, the surface integral, it's going to appear when we go ahead and convert it. So now that we know what all the different pieces of this are, let's go ahead and try to work with them. So our first step is to identify the region R below the surface. So I did that. They gave it to me. It's 2 less than or equal to x less than or equal to 3. So if I wanted to, I could go ahead and say somebody gave me that x is going to go from 2 to 3. And y is going to go from 2 to 3. And then my next step is to identify my function f to evaluate. That's the thing I want to find the surface integral of. So the function g that they gave us is what we referred to as f in the formula. That's the thing that we want to have inside the integral. And I know that I'm going to have that g doesn't depend on my 3D variable. So I want to get rid of the z's using my surface. That was kind of like that last hint. So you could do it right now, or you could not recognize that fact until later. That's also okay. But we'll go ahead and do it right now. So my surface was 2x minus 3y plus z. So I'll go ahead and say, okay, z is equal to 6 minus 2x plus 3y. So g when I replace all my occurrences of z with this thing, becomes x times 6 minus 2x plus 3y plus 2x squared minus 3xy. And so that thing could go right here. I know that in my formula, f is right there in the integrand at the end. So x times 6 minus 2x plus 3y plus 2x squared minus 3xy. Okay, but this does look like something I could evaluate. There's only x's and y's inside, and I have an integral with respect to x and y and bounds for x and y, but I have to remember that I'm not just integrating over the region R, my function, I'm trying to integrate over the surface S. So I have to remember this square root thing that looks like finding surface area, because what I'm actually doing is I'm thinking about the size of the surface everywhere that I'm thinking about the size of f inside my integral. So I need that thing right there. And so my fx squared from when I calculated z, this should be familiar to all, is 4, and my fy squared from when I calculated z is 9, just like when we were finding surface area. Oops, I think I wrote it in the other order. So I have 4 plus 9 plus 1. And if I wanted to clean this up a little bit, I would have, this is 6x minus 2x squared plus 2x, well, I'll do it, minus 2x squared plus 3xy. And then it gets a plus 2x squared minus 3xy. Here's this component versus this component. And so most of the terms cancel out, and I'm actually just left with 6x root 4 plus 9 plus 1 is 14 dx dy. And I'm not going to calculate this integral because I don't think it's a good use of your time. And I'm pretty sure that you could do this from this point. So the tricky part here is really just setting up the surface integral so that you can evaluate one of these 2D integrals that y'all are pros at by this point.